Welcome to the Unit 3 Day 9 video on linear inequalities. Today we want to understand the meaning of a solution to linear inequalities, to graph a linear inequality, and to write an inequality given a graph. A linear inequality in x and y is an inequality that can be written as follows. ax plus by is less than c, ax plus by is less than or equal to c, and so on. An ordered pair is a solution of a linear inequality if it makes the inequality true when values of x and y are substituted into the inequality. For example, if I want to check whether the ordered pair -3, 5 is a solution to the inequality 4x plus 5y is less than or equal to 12, all I have to do is substitute in the values of x and y into the inequality. Alright, so 4 times -3 plus 5 times +5. And I want to know if that is less than or equal to 12. That's -12 plus 25 less than or equal to 12. Is 13 less than or equal to 12? No. So the ordered pair -3, 5 is not a solution to the inequality. If I try 0, 2 as the ordered pair, then I would put again 0 in for x, +2 in for y, and I check. 0 plus 10 is less than or equal to 12. Yes, 10 is less than or equal to 12. The graph of a linear inequality in two variables looks like this. We have a line and we have a colored in side or half plane. The graph of 2x minus 3y equals -2 is shown. Every point that's in the colored in part of the graph is a solution to the inequality. So the point 2, -1 is a solution, and you could check by plugging in x and y. And the point 0, 1, since it is not in the blue part, is not a solution, and you could verify that by putting in 0 and 1. Okay, and so this should actually be greater than. So to graph linear inequalities, first thing is you have to graph the line, or graph the corresponding equation. So you're going to make an equation, you're going to graph it. You're going to use a dashed line if there's no equality underneath the inequality sign. And you use a solid line if the inequality has the line or the equality underneath it. Then we need to test a point in one of the half planes, or one of the two halves of the picture. So the line will cut the picture into two parts. You test a point on either side. And if the test point works, that is the side that you color in. For example, if I wanted to sketch the graph of y is greater than -3, first, the step one is I have to graph y equals -3. And to graph that, we use this saying, hoi vux. And if it's y equals, we know we have 0 slope. It is a horizontal line. Another way to think of this is that if it is a 0 slope line, this is y equals 0x minus 3. So the slope is 0 and the y-intercept is 0, -3. So if I label my x and my y-axis 0, -3, a 0 slope would mean it's completely horizontal. So I'll use my ruler here and line it up. And now, then I have to check, is it a solid or a dashed line? Well, because it is no equality underneath, we're going to make it a dashed line. So I'll not make it solid, I'm just going to make a dashed line like you see in elementary school when you have to cut with scissors. I make it a dashed line. And that means that it's any point on the line is not a solution. Okay? To show that points on the line are not solutions when they are dashed. Okay, step 2 is we need to test the point. So you need to pick a point either above or below the line, And I would recommend picking the point 0, 0, because that would be the easiest point to test. But you can choose any point. You could have picked up here or over there or down even below. So I'm going to pick 0, 0, and I put 0 in for y, and I want to know, is that greater than negative 3? And it is, right? I took the y value 0, put it in for y into the equation, and it made the inequality true. So that means I need to shade or color in the part where this point was. And since the point was above the line, I'm going to color in everything above this line. Okay, so anything in this blue area would be a solution to the inequality. Let's do another one. Step 1, make it an equation. So I'm going to make x equals 1. And to graph x equals 1, again, I'm going to use Hoy-Vux. And this time we have x equals. And that means my slope is undefined, which means that it's going to be a vertical line. And the vertical line is going to pass through x equals 1. So here's x and y, of course, x, y. Here's x equals 1. It's going to be a vertical line. Now, is it dotted or solid? Well, if you check, the equation has a line underneath. So in this case, I'll use red, and I'm going to graph it as a solid line, like this. Okay, it was solid this time and not dashed because I had the inequality underneath. All right, the next thing I have to do is test a point. Now, you could use 0, 0 again, but let's just, for the sake of trying a different point, let's do 4, 3, x and y. So I'm going to test 4, 3. I put into the equation for x, 4, is that greater than or equal to 1? It is. So then step 3 is to shade. So now that I know that that point was a solution, I will shade on the right side where that point was. If I'd picked a point on the left side, it would not have worked, and so I'd pick a point on the other side. And there you have it. All right, is negative 2, 3 a solution to this inequality? And of course, you can check that by having negative 2 times x, which I used purple last time, so I'll keep using purple. And I want to see if I add y, if it's greater than 0. Well, I put a 3 in, and let's multiply. Negative 4 plus 3 is greater than 0. Negative 1 is greater than 0. That's not true, so no. This point is not a solution. Just to show you visually what that looks like, let's graph this inequality. So step 1, first I write as an equation 2x plus y is equal to 0, and let's graph it. And the way I graph it is by making it into slope-intercept form. So I will add 2x to both sides. I have y equals 2x. What's the slope? It's going to be 2. The y-intercept? Well, b is 0, so the y-intercept is 0, 0. So let's graph the line. 0, 0. And then is it solid or dashed? Solid or dashed line? Well, there's no equality, so it's going to be dashed. So I'm going to go ahead and plot my points. My slope is 2, so I go up to 2 over 1. Now I'll take my ruler. See if I can do this. Again, it's a lot harder to do this on a computer than on actual paper. All right, almost there. I think that'll be pretty good. So let's line it up. And then draw the line. And I drew it straight here, and I made it solid, which is a mistake, so I'm going to erase small pieces to make it a dashed line. Now I pick a point to test, and you see on this line I can't pick 0, 0 because it's right on the line. So we pick the point negative 2, 3. Negative 2, 3. This is the point, and we already tested it. we tested negative 2, 3 to see if it worked, and it did not work. And because it did not work, you see that it's on the top side of this line, this dashed line, and that point was not a solution, so we do not color on that side of the line. Oops, I don't know what's going on there. I want to undo that. Oh well. Let me erase. So I have to color on the other side because the point negative 2, 3 did not work. So I'm going to color in on the other side because that point negative 2, 3 did not work. So I will color in on this side. And the last thing we're going to do in our video today is write the equation of an inequality. So we have this dashed line, so we know that it's going to be either greater than or less than. We know how to find the equation of this dotted line if it was an actual line. And so if I have y equals mx plus b, you can find the slope pretty easily by counting between two lattice points, or 2 points that are right on the grid. So I know that I go up 1 and over 1, 2, 3, 4, 5. So my slope would be 1 divided by 5 plus b. Okay, and what's the y-intercept? Well, it's negative 1. 1/5 x minus 1 is the equation of the line. Well, how do I know whether it's going to be greater than or less than? Well, you can test the point, of course, 0, 0. And so 0, 0 minus 1, 0, negative 1. Well, which one is bigger? Well, I'm sorry, I should have tested the point in the other side. That will not work. I'm sorry, I made a mistake. We're not going to test 0, 0. We want to test the point that is in the solution set, or in the shaded part. So let's test the point 1, negative 2. 1 for x, negative 2 for y. Negative 2, we have 1/5 times 1 minus 1. All right, obviously they're not equal. Let's see which one's larger. So we have 1/5 minus 1. That's 0.2 in the calculator, 0.2 minus 1. So negative 2 is what relationship to negative 0.8? Which one is larger? Well, negative 0.8 is. So my equation of this inequality is y is less than 1/5 x minus 1. Thanks for watching.